miserable morning, and because of that, and I'm in a not miserable mood, I'm going to give you a little bonus. All right, anybody think about a bottle of vinegar? It has acetic acid, it's a carboxylic acid. Remember that. Did anybody happen to look at a box of fabric softener and think about it has a quaternary ammonium salt in it? That you should remember too. And that's my gift for this morning. This is the first gift. The rest will be what I'm going to talk about. It's going to be fun. Remember, this is one of my comfort areas, so look out. All right, talking about amines. Amines are compounds that have nitrogen and carbon and hydrogen. And I was talking about how you make amines. And yesterday, I believe I talked about how to make a primary amine. Did I do a synthesis problem with primary amines? This one. Well, I better check out with the second one. And let's try one. And since I already discussed this reaction, I'm going to let you try this. Start out your morning with some fun. What would be the organic product, starting material, to react with ammonia to make that compound? And as I just looked out the weather window, it's still raining. Good morning. Good morning. All right, looks like everybody's done. Let's take a look at this. And the first thing you should always do when you look at organic molecules, identify the functional group. Or another way of thinking of it is, what's different? What's not carbon? What's not hydrogen? What's not carbon-carbon single? Nitrogen, get your attention like that. This is a primary amine. I forgot. Sometimes I will do that. And what do you react with ammonia in the presence of base to make a primary amine? An alkyl halide. And here X is the halogens you're familiar with, chlorine, bromine, or iodine. Therefore, what's my R group? This. And therefore, I'm going to have a ring. Uh-oh. I'm having a bad ring drawing day. That's better. You don't break carbon-carbon single bond, so I still have the methyl group. Which carbon has the amino group? This one right here. And that would be the carbon that has the halogen. You can pick any one you want. I'm going to pick bromine, you could put chlorine or iodine, all of it is correct. And that's how you make a primary amine. Now, once you have a primary mean, what can you do with it? Well, I'll teach you things where primary means are important in our daily life later on, but you can use that to make a secondary mean. And remember the non-bonding pair of electrons on nitrogen, which carbon doesn't have and nitrogen does, is a nucleophile. It's looking for anything positive. And the carbon with the halogen is slightly positive, and this attacks that. You learned about nucleophilic attack in the lab, and it kicks out the halogen. You lose a hydrogen there, HX, an acid neutralized by the base, and you get a secondary mean. Remember, the carbon with the halogen in R prime is the carbon bonded to the nitrogen in my secondary mean. And if I look at the following reaction and say, what's the organic product or products we're following? Now we're getting to the fun part where we're dealing with multiple organic molecules. And each one, you should identify what functional group you're dealing with or what's different. Ooh, nitrogen. On carbons, primary amine. Carbon, ooh, with the halogen, alkyl halide. In the presence of base, you know what you're going to get. I already have it up there. A secondary amine. Notice you have a reaction in stereo now. But anyways, what's my R group? This. What's my R prime? This. And therefore, I'll put my nitrogen. What's R? 2 carbons. What's R prime? 1 carbon. And notice you're going to lose 1 hydrogen because amines have 3 bonds to them. Therefore, if I have 1, 2, 3 minus 2, yes, you're right, is 1. For your fun and enjoyment on this one morning, why don't you try this one? What would be the organic product or products of the following reaction? Does this look okay from back here? Remember, I can change the font. Size. All right, let's take a look at this. The question is, what's the organic product or product? Remember, this is how we build things that we use in our daily life. Anybody look at mouthwash and see if it had a quaternary ammonium salt in it or not? Anyway, what do we have that's different here? Nitrogen is a primary amine. carbon, halogen on the carbon, alkyl halide. In the presence of base, what happens? Nucleophilic attack on the carbon with the halogen bonds to that. Therefore, what's my R group? Methyl. What's my R prime? This, which is called a sec-butyl, which you learned about in lab, and I'll never put it on a test the name-wise, but structure. Therefore, I can do this. This will be easier. This is my R prime, which carbon has the halogen, this one, and it will be the one that's bonded to the nitrogen. R prime will be on, R will be on the nitrogen, methyl. I'll have one hydrogen. And I make this amine. Now, on the test and in real life, the fun part of organic chemistry is not, if you mix two things together, what are you going to get? It's, how do I make this molecule? And that's what organic chemists do in the real world, in industry, because no one's ever going to pay a chemist to say, if I mix this and this together, what am I going to get? No, they're going to say, how do I make this molecule? And I'm going to let you try this one on your own, then I'll show you how to do it. The question would be, what would be the starting material used to make this product? Like the last carbon just went down. Before I do this and go through it, I'd like you to think about something. 6 months ago, if I put this on the board, first showed you that general reaction, like over there, and put this on the board and say, what are the starting materials? Would you even know what to do? Think how much you've learned. Aren't you proud of yourself? We're deep into organic chemistry. Hopefully you're finding it fun. I am. All right, what's different here? Nitrogen. 2 carbon or alkyl groups, secondary amine. What do you react in the presence of base to make a secondary amine? A primary amine plus an alkyl halide. And let's see, do I have one? I do, because I'll need this. And now I can say this ring I'll call R, and this methyl group I'll call R prime. And if that's the case, the carbon with the nitrogen will be the one in R with the nitrogen. The carbon here, R prime, will have a halogen. You can pick whichever one you want. And let's see, I haven't used chlorine in a while. So that would be one answer. But there's another answer. And this always happens, not always, but it's common in organic chemistry. There's more than one way to make something. And therefore, I could call this R prime and this R. And therefore, what would be our primary amine? What would be our prime? And again, I could use chlorine, I could use bromine or iodine. Which one is correct? They both are. Now, if you're at my level, you'd know this is cheaper than this, but I'm wondering probably the only person in this building right now would know that because I work with amines and I know what's cheaper and easier to make. But either one is the same. All right, now let's continue on. Remember, the driving force for this reaction is the non-bonding pair of electrons on nitrogen doing a nucleophilic attack on the carbon with the halogen. Well, if you look at a secondary amine, it still has non-bonding electrons. You have the secondary amine, and the non-bonding electrons can do a nucleophilic attack onto the carbon with the halogen, kick it out, lose HX, which is neutralized by your base, and therefore you will now get a tertiary amine. Now, common question students ask me at this point is, how come there are no hydrogens on the nitrogen? Well, if there are 3 bonds to nitrogen in an amine, 3 minus 3 is 0. That's why there are no hydrogens. Now, I will be using this on the test just like I'm using it on the board. Let's take a look at this reaction. What's different? Ooh, an amine. But notice I have a methyl group inside a bracket to the right of the end right bracket, subscript 2. That means there's 2 methyl groups on this nitrogen, secondary amine. In this case, both R and R prime are methyl groups. Then I come over here, what's different? Carbon, carbon, iodide, and alkyl halide. And this is my R double prime. What do I get? My nitrogen. What's attached to it? R and R prime, which I can write this way. And then I have an ethyl group. Now, you could also on the test, if you like to, I'm going to write it down here because I don't have enough room there. You could also write this and 2 sides have methyl, 1 side has ethyl. There are other variations I could write it. Which one is correct? Either one. On a test, I'm going to use this because this is easier with my software. Now, organic chemists, if you haven't learned by now, are lazy. There's an easy way to do it, we'll do it. And why don't you try this one? What would be the organic product or products for the following reaction? All right, quick reminder for those of you who have lab tomorrow, don't forget to wear proper clothing, as always, no open-toed shoes or stuff like that. Also, because of some changes, and I'll talk more about it in lab, Part A, the Toland's reagent test or silver mirror test, I'll be changing that so you don't have to write your to-do list part for that first one. The others you do. All right, let's take a look at this. And the question is, what's the organic product or products that are following? What's different? Nitrogen. It's an amine. Notice two alkyl groups. It's a secondary amine. I come over here, carbon halogen. Alkyl halide. In the presence of base, what happens? Nucleophilic attack, I lose HX, it's neutralized by the base, and I get a tertiary amine. And now if I look at this, what's R? My methyl group. What's R prime? My ethyl group. And what's R double prime? Isopropyl group. And if I construct this, I can make it, there are different ways I can draw it. I can put my methyl group, the other R prime, okay, double prime. When it rains, I lose count of primes. And now, notice, the carbon with the halogen is attacked by the nitrogen. Therefore, that's the carbon that will be bonded to the nitrogen, center of 3. And that would be the molecule. Now, listen carefully. This also is a common question students ask. Well, what if I put my ethyl over here and my methyl here and isopropyl there? Would that be correct? And the answer is yes. All you're doing is just rotating the molecule around. And therefore, the answer would be one side has a methyl, another side has an ethyl, and the third side had an isopropyl. And that's just one representation. And why don't you try this one? What would be the starting materials for this reaction to make that product? Well, I haven't done this in a while, so you get the hint. On this one, maybe. Depending, either 3 or 6 points, depending on my mood. That looks like you guys are getting the hang of it. It looks like everybody's done. Let's do this. And if we look at this one, the question you should ask is, what functional group is in this molecule? What's different? Nitrogen, 3 alkyl groups, tertiary amine. How do you make a tertiary amine in the presence of base? You react a secondary amine plus an alkyl halide. Now, I could call this R, and this R prime, and this R double prime. And therefore, if I do that, I would have this dimethylamine. You could have, instead of the brackets, 2 methyl groups. and then my cyclohexane ring would have the halogen, and I can pick any one I want. I haven't used iodine in a while, and that would be one choice. Turns out there could be another one. I could call this R prime, and this R double prime. And if that's the case, then my secondary amine, let me erase this. One R group, R prime is cyclohexane, R is a methyl. And then R double prime is a methyl. And I'll stick with iodine. And either one of these would make the correct product, which is cyclohexyl dimethylamine. Now, one of the things I've been doing a lot in this semester is asking you to remember the question, why am I learning this stuff? And besides the obvious reason someone told you had to take a class to get a good, you want to get a good grade so you can get into a program or a school, why else are you learning this? Let's take a look at this molecule. It's called dimethyl cyclohexylamine. It also has a trade name, polycat 8. Notice 6 plus 2, 8 carbons. Poly means polymerization. Cat stands for catalyst, and this is a special catalyst used to make urethane foams. And catalysts make reactions go quicker, so you just don't sit there forever and wait until it's done. And in this reaction that uses this, you want it to be quick. What does it make? The foam you're sitting on. The foam you're sitting on has been made using this catalyst. Well, how do they make this catalyst? One of those two reactions, because it doesn't exist in nature. So when you ask yourself the question, why am I learning this stuff? Well, it's stuff in your everyday life to make things like you're sitting on right now. Or when you came here in a car or another vehicle, I'm assuming you weren't sitting on a wood bench. You were sort of plastic. It was something that was comfortable, cushiony, and that was a urethane foam made with that catalyst. All right, now, once you have a tertiary amine, guess what? You still have two non-bonding or lone pair of electrons. And you can make a special molecule, which I call quaternary ammonium salts, and so do organic chemists. And now we're talking about a reaction that's near and dear to my heart, because this reaction helped pay my mortgage and a few other goodies and got me to, let's see, South America, Europe, Canada, most of the number of states in the United States. So if I like this reaction, you better believe it. And what's that reaction? If you take a tertiary amine plus an alkyl halide in the presence of base, this will attack that. Notice there are no hydrogens to lose. So therefore, what happens is you get this. A quaternary ammonium salt. And the base is there to neutralize any acid that might be formed, which is minimal. Not as much as primary, secondary, tertiary, but it's still good to have there. And this is how you make quaternary ammonium salts. What do you use them for? Fabric softener, biocides, hair conditioner. Yes?
I'm seeing a triple prime on the
I told you when it's raining, I lose count of primes. There, triple prime. Thank you for letting me know about that, Alice. All right. And this should be, hold on a second, must be the pen. That pen. Yeah, this one works right. All right, let's take a look at this. Let's do a reaction. Let's do one that's very important to me for many years. And remember, R sub T is tallow. I'll teach you what a tallow alkyl group or tallow group is. But think of it as this alkyl group with a lot of carbons, like 16 or 18 carbons. But if we look at this, what is this? Tertiary amine. We can call two of these R and R prime. See, this pen's working better already. And the methyl group, I'll call R double prime. It doesn't matter which you assign. And now if we look over here, we have carbon with a halogen, chlorine, and I'll call this R triple prime. And like I said, the pen is working. What do we make? Quaternary ammonium salt. I have a nitrogen. Notice R and R prime are tallow, so I can write it like this. Or I could have also written it like this. And then R prime is a methyl, R double prime is a methyl. R triple prime is a methyl. This will have a positive charge, which is my halogen, chlorine. And you could write it this way. This I could also write this way. And over here, another way I could have written it would be this. All of those are identical. One second, let me check to make sure I'm doing this correctly. Yes?
Two things. For that T, is that a T for the R?
R sub T is a way of abbreviating a special alkyl group. That stands for tallow.
Okay, and then, can you get, like, just, maybe not go to a specific store, or possibly order it online for ammonium salt? Or is
You
that-
can't unless you're part of the company. I don't think you can. You can't go and buy a fabric softener that's mainly water and a quaternary ammonium salt, or you can buy mouthwash and it's got another quaternary ammonium salt. In fact, for a while, until I found a better way of doing it, sometimes the mold and the grout in your bathtub, mouthwash will clean that out. It's biocide. But there's a better way, and when we get into fats and oils, I'll teach you. But you can't directly. I can't either unless I set up a company and have a credit line, then I could. All right. But let's get back to this. If we look at this is a reaction where I work, we made about 20 to 30 tank wagons a week of this molecule. A tank wagon is 40,000 pounds, so we were making at least 500,000 pounds a week of this, which means we sold a lot of it. It was a very good profit margin on selling it to people. And who are our two biggest customers, as you learned yesterday, Procter & Gamble and Hoover. And the company I work for, we went through a lot of methyl chloride, which is the alkyl halide I have over there. And now I'm going to let you try it on your own. What would be the organic product or products for the following? Ooh, I forgot to talk about coming attractions either tomorrow or next week. One, I'll talk about the dark side of organic chemistry. There are molecules that are dark or evil. And I'll also talk about either tomorrow or maybe next week, probably one of the dumbest things I ever did in my life. Which, having told you, you won't do the same thing. But one of the things on a serious note, I'll ask again, a couple people asked if there were any volunteers. I haven't, I think one or two might have told me, but send me an email if you're interested in working with another student in the class, one of your colleagues. And what I've done this before, just connect two people together, you work out what works best with you. And usually what students do is they'll sit down when they have some time, when they're both here at COD, and they'll practice together. And the student who got better on test number 2 will help the student who needs a little extra practice. And by the way, if you're the one who did better, that also helps you a lot more too, especially for test number 5 and the ACS final. But let me know by email, say today or tomorrow, if you're interested in helping someone out. All right, let's take a look at this. The question is, what's the organic product or products you're following? And we look here, what's different? Nitrogen. Notice it has 1, 2, 3 alkyl groups on nitrogen. Tertiary amine. Alkyl halide. And in the presence of base, what do you get? My favorite molecule, one of them, is a quaternary ammonium salt. And remember, this has an anion. Now, I had a Chem 12 student who didn't like writing charges, and he talked about that in carboxylate anions. And if you don't put the charges there, I will never mark it wrong on my tests. All right, so if we look at this, what is R and R prime? My 2 ethyl groups. What's R double prime? My methyl group. What's R triple prime? Isopropyl. And now if we put it together, I have my nitrogen. What's attached to it? R and R prime, which I can draw this way. There's other ways of drawing it. And then what's also on there? Well, the methyl group. It doesn't matter which side you put it on. And then we'll have an isopropyl. Remember, the non-bonding electrons attack the carbon with the halogen, in this case the center of 3. What's my anion? Bromine, which becomes the bromide anion. And that's the quaternary ammonium salt you make. And the question would be, what's the starting material for the following reaction? I'm so proud of you. You're all jumping in and do that. Thank you. move the clock. Get it started. All right, looks like everybody's either done or still pondering. Let's move on. All right, let's take a look at this. The question is, what are the starting materials needed to make the following molecule? And the first question you have to ask is, what functional group are we dealing with? What's different? Ooh, nitrogen. It's got a plus charge in the anion here. It's got 4 groups on it. This is a quaternary ammonium salt. And what do you react to make a quaternary ammonium salt? Tertiary amine plus an alkyl halide. And now I can look at this and say, oh, why don't I make these methyls R and R prime? One of these 2 ethyl groups I'll make R double prime, and the other one I'll make R triple prime. And therefore, if I come back here, I'll say, well, my nitrogen on the tertiary amine has R and R prime, 2 methyl groups. And then R double prime is an ethyl group. And then my alkyl halide is an ethyl group. And that's going to be a chlorine because you get the chloride anion, and that's one possibility. The other possibility is I can call this R and R prime. One of these I can call R double prime, and the other one R triple prime. And therefore, if that's the case, my amine will have 2 ethyl groups, and the other group is a methyl group. And now my R triple prime is a methyl group. And that's what you would get. And that's how you make quaternary ammonium salts. Which, like I said, got me to many places. I cannot talk in this group, one sec, about the consulting work I did in Guadalajara. By the way, Guadalajara is almost a wild city as Amsterdam. Yeah.
Working with the other problems, does the location of where we write the anion matter?
No, I think it's convention to write it on the right of the molecule.
Okay, it doesn't matter
Now,
at
as
all?
long as you get it within a couple inches of the molecule, not on the next page, I'll consider it correct. You can put it on top. I've seen people put it on bottom to begin with. I'll look at it, I'll smile, and say, oh, that's right. If you haven't guessed by now, I don't grade to see how many points can I take away from people. That's not my style. So it's a good question, like all questions. If you were to put, like in this problem here, instead of putting the bromine here, say you put it over here. It'd take me a second or so to look and find it. I'd find it. If I marked it wrong, hopefully you'd come and tell me you made a mistake and I would correct it immediately. And by the way, you have everybody else around you as witnesses, I said that. All right, now it turns out there's one really excellent way of making primary amines, and that's with a nitrile. And nitrile is a functional group I haven't talked about yet. And I won't go into the nomenclature. There is both common and IUPAC nomenclature for nitriles. And nitrile is a carbon-nitrogen triple bond. And with any multiple bond, in the case of a triple bond, that's 2 pi bonds and 1 sigma bond. You've seen pi bonds before. What can you do with them? You can break them with hydrogen. So therefore, and yep, I forgot on the slide. Since you'll need more than 1 mole, I'll usually put down in a test, if I put it on a test, excess. And each pi bond is broken, just like in a carbon-carbon triple bond, and each atom of the triple bond gets 2 hydrogens. And another way of writing this would be this molecule, and it's a primary amine. And this is probably one of the best, if not the best way of making primary amines if you can get your hands on nitriles, which are not that hard to make from carboxylic acids, which is chemistry I won't go into in this class. So if we look at the following, remember, catalyst is nickel, platinum, or palladium. And if we look at this reaction, first thing is, what's different? And if I look at that and I say, ooh, wait, what's not a carbon-carbon single bond? Nitrogen's a carbon triple bond, nitrile. Reacting with excess hydrogen catalyst, what happens? You break the pi bonds, which there are 2 of them, and each atom of the triple bond gets 2 hydrogens, and you make a primary amine. Now, do you break carbon-carbon single bonds? No. So it's my R group, this, and therefore I have 4 carbons, and then this carbon right here, and the nitrogen, and you make that amine. By the way, say hello to my old friend up there, pentylamine. The first research project I had in industry when I joined, which was then called RMAC, is now Axo Nobel, was to find out and develop the process to make that amine by that reaction. And I found out, and then I found a better way to do it that didn't use that reaction that led to my first patent. And that's called hydrogenation of the nitrile, or reduction of the nitrile. And based on the rustling I hear, I think I'm out of time. Oh, wait, I have a whole 25 seconds early. I'll let you out. Be careful. Oh, quick safety thing. For those of you who don't know, roads are crowned. If you're on a 3-lane highway, stay in the center lane. If you're on a 2-lane, stay in the lane not next to the curb. With that, I'll see you.